Welcome to the grocery store. In math, when we want to talk about a specific group of things, like all the apples in the produce section or all the cans of soup on a shelf, we simply call that a set. If you look at a carton of eggs, you can count them 1, 2, 3, up to 12. Because the counting stops at a specific total, mathematicians call this a finite set. But imagine if you turn down the cereal aisle and it just keeps going. No back wall, no exit doors. An endless line of boxes stretching into the dark. That is an infinite set. Now, here is the puzzle. If you have two different aisles that both go on forever, are they the exact same size? Or could one endless aisle actually be bigger than the other? To find the answer, we have to look at the mechanics of how we measure, because once we do, we find that infinity operates on distinct, measurable levels. To measure these levels, let's meet our store's inventory manager. Their job is to track the stock, and they use an endless row of price tags printed with 1, 2, 3, and so on. In math, these are called the natural numbers. The manager has a rule for taking inventory. A group of items is countable if you stick exactly one unique number tag on every item in a sequence, ensuring absolutely nothing is skipped. The manager walks down the endless cereal aisle, placing tag 1 on the first box, 2 on the next, 3 on the next. The counting never stops. Because you can always identify the next box to tag, this is called countably infinite. As long as the items are separated into a neat, orderly sequence, an endless amount of them can be accounted for. But imagine a delivery truck unloads a second endless line of boxes. In math, this is like adding negative numbers to positive ones. The manager still only has one roll of stickers. How do you count two separate, endless lines at the same time? If you start tagging the first line, you'll never reach the end of it to move on to the second. To count both, the manager simply zigzags between the lines. Tag 1 to the top row, 2 to the bottom, 3 to the top. By weaving back and forth, every single box eventually gets a tag. The combined total remains countably infinite. So our manager has a checklist. If a set stops at a specific number, it is countable. If it goes on forever but can still be lined up in a sequence, it is countably infinite. Sequencing is a powerful tool, but it has a limit, and we are about to step into a section of the store that breaks the rules of counting entirely. Let's walk over to the deli counter. Sitting there is a solid, smooth block of cheese that stretches on forever. This block represents the real numbers, which includes every possible decimal and fraction. The manager tries to take inventory. They stick number 1 at the absolute left edge, position 0.0. Then, they try to place sticker 2 on a slice immediately next to it at position 0.1. This diagram reveals the problem. When we look closely, the gap between 0.0 and 0.1 expands to show infinite smaller slices packed inside. The cheese is solid. Slicing the gap between any points always reveals more space and more fractions wedged tightly between them. Because of this density, you can never identify the definitive next slice. There is always a smaller slice hiding in between. Without a next item to point to, the sequential 1, 2, 3 sticker roll cannot be used. Mathematicians call sets like this uncountable. They are so dense and gapless that they cannot be placed into any ordered sequence. The continuous block of cheese cannot be labeled piece by piece. It is a structure where individual points are packed so tightly that a sequential list can never describe the whole. Looking out over the store, we can see the divide, the distinct items in the aisles, and the smooth, continuous sections at the deli. Since the uncountable set contains an infinity that you can't even begin to sequence, it represents a larger size of infinity than the countable aisle. This is why we can count the individual coins in our pocket, but the continuous path we take to walk across the room is made of an infinite number of points that we could never list out. Infinity is a landscape of varying sizes, rather than a single number. If you enjoyed exploring this landscape, share this grocery trip with a friend.